Welcome to some more Flat Earth Science. Today we're going to talk about why and how the world is flat, how it works, why we have two separate star rotations in the night sky, all seen through time-lapse video, modern camera work now. Equatorial mounts, following stars, time-lapse. We see the gap between the two rotations. The Egyptians, Plato's dialogues, many books on the subject of there being two separate rotations, because Earth is a duality. It's a dual system, and science doesn't want you to know about this, because as soon as you realise it's a dual system, you realise it's flat and there's no way around it. So dual system, I'm going to go into Edmond Halley and read some of his information, which is very hard to find. It's not out there in your face, they hide it. He found exactly what I've found. He's looked into everything I've looked into. He had a brilliant mind, scientific, unlike me. So we're the same, but we're not the same. And I'm going to explain it all today in this video, but the video is only 27 minutes long, so I have to get as much as I can out. But anyway, the dual system, the north and the south, right? This is what it looks like. There's a slice through the middle. You've got a vortex in the middle. We don't see any of this, but in here is what drives the whole system. This is the negative flowing through the Earth, the positive flowing over the Earth. And if I just draw this is basically Earth's sine wave. Like this. And this is Earth. Earth is through the middle here. This is positive, negative. It's just the way it goes. Earth through the middle of it. Negative, positive, or positive, negative. That's the sine wave. When they try to put it on a spinning ball map or whatever, just ignore it. That's it there, and it works from here over to the tropics, down through the Earth, and back up out here, and vice versa. Put that aside, it wasn't part of the plan. Where's my rag? Not part of the plan today, but anyway. So here we go. That's not it either. Right, these are solar winds and the magnetic field. Solar winds carry the magnetic field, and the magnetic field in return carries the solar winds. Science doesn't want you to know this. They'll have solar winds here. They'll show you the solar winds, exactly what's happening here, but they'll want you to believe you live on a spinning ball and the magnetic field comes from here all the way around and goes in there. They don't explain why or how, why would it go all the way out here, back in and back down in here? Pure rubbish. So, okay, the solar winds are the magnetic fields, and the magnetic field is the solar winds. They carry each other. The solar winds and the magnetic field lines are curved because of the center Earth's magnetic vortex spin. In here is the spin. In here is the spin. It drives everything. It's the convergence point of the whole system. High pressure, low pressure, meeting. So coming out of here is turning this whole northern district, whole northern region. That's what we see in the night sky, Polaris, what turns Polaris. And what is turning, the coming out of here turning this, is causing the southern field to turn. So it's revolving out like this. As it goes round, it's pulling the southern field like this. It pulls, because the southern field, the magnetic field comes out, solar winds come out, and they're heading straight to the tropics, because this is high pressure, where the ice is. Thin dry air is high pressure, and it races to the low pressure. Racing to the low pressure, but on its way it's getting pulled because the force of in here, the centripetal force is driving everything. Our whole system is made up of waves, curves and vortexes, spirals. Nothing is linear, nothing moves in a straight line. Everything on earth and nature moves in curves. The Arctic vortex is seen turning the northern star's rotation around Polaris, the sun. Polaris is the sun, because it's right in the centre. It's in the centre, and it's straight up. There's Polaris, straight out for Sigma Octantis. This is the powerhouse to our Earth, the magnetic vortex. The convergence of the magnetic fields, the convergence of the high and low pressure. Its force also drives the southern magnetic field, solar winds. Energy coming out of here, turning everything, like I've just shown, pulls this field, turns this field. It's just freely flying out of the south towards the tropics. This is the high pressure, low pressure. That is the duality. The opposites attract. They do not go from the south all the way up to the north in a ball. The high pressure is attracted to the low pressure. This is an observable fact seen in meteorology, where the solar winds meet at the tropics and are pulled westward, as does our whole sky system. Everything moves west. You look up, our whole sky moves west. Sun, moon, stars, planets, everything is all moving, because it's all being rotated around this way, west. And what science isn't telling you also, it gets pulled to the tropics, down, because the high pressure being pulled down by the low pressure being pulled up, and travels through the earth. It's a trinity. The pressure, electricity, and the magnetism. Magnetic, high pressure, negative electrons. We've got 4 there, but magnetism, electricity and solar winds all acting together. So what is magnetism but pressure? High and low pressure, opposites attracting. There's high pressure racing to low pressure and vice versa. That's a good example. What have we got here? We've got pressure. Spin it round, low and high, it's attraction. Simple. It's basically what magnetism is. Pressure, density. There is no denying Arctic dry air, which is high pressure, is racing to the low pressure of the tropics. Therefore, science cannot deny that Earth has a dual system. 1, 2. A northern rotation and a southern rotation, both obviously seen in the night sky. Science is frantically denying this because this alone proves that Earth is flat. Their only objection to this obvious conclusion is for them to deny the magnetic field is in the solar winds. Then steps in Edmond Halley. Halley's lines, or isolines, or contours. I challenge anyone to research all his work. You will find he has found exactly what I've found here. The difference is I never had to leave home and sail any seas, because everything adds up if you put your mind to it. So I'll read some of Edmond's work. So these are the field lines, magnetic field lines. They're two separate. You will not travel from the south directly to the north. You will follow the magnetic field. Your compass will follow this. You're aiming north and you end up way over here and you go, what the hell, what am I doing way over here? I'm trying to head there. But it's all explained here. Geomagnetism and Edmond Halley. Then they show you a bit of bullshit. It had nothing to do with Halley. Pure bullshit. But there, I don't know if you can see them, but you can see the magnetic field lines. They converge towards the tropics. They curve west. He's got them. When one reads or hears the name Edmond Halley, the comet of the same name often comes to mind. Relatively rare, comets have appeared throughout history and for millennia. Humanity viewed comets as independent, if not prophetic events. In 1682, another comet appeared to the world. Halley was one of the most eminent astronomers of the 17th and 18th century, argued that the comet of the 1682 had been the same one that had been recorded in 1066, 1305 and 1380. Rather than a parabolic trajectory, this comet, he argued, travelled on a highly elongated elliptical orbit. Using the new mathematical and physical developments of his friend Isaac Newton, Halley predicted that this comet would appear again in the world in 1758. Halley, who would become Britain's astronomer royal, never lived to see the prediction come true, but Halley's comet was born. Not confined to only astronomy, Halley's great mind touched many areas of science and technology. To electrical engineers, it may come as a surprise that Edmond Halley was also one of the early explorers into the realm of electromagnetic phenomena. It was in the 13th century when the compass first appeared to Europeans, though in China it had come about 2 centuries earlier. As crude as these early compasses were, they marked a great technological revolution. One could argue that the compass was the first electromagnetic technology. For the first time, mariners had a tool for navigating on the differentiated ocean, regardless of the conditions. As explorers ventured further out into the world's oceans, they discovered that the compass did not point to the geographical north. This difference between geographical north and magnetic north was called variation. Now, science hides the guts of what Halley was on about. They want you to just concentrate on this little variation up here between geographical north and geomagnetic north. But when you're way down here, that's stuff all to worry about. The big concern was this. These longitudes would get these sailors lost every time. or confused. And now all this is all hidden by that little mention of variation. They want you to concentrate on just this little variation up here. Mariners were further perplexed by the ever-changing value of the variation as one moved on the globe. I'm not even sure if did he know it was a globe back then? The fact that the compass behaved oddly could be frightening to sailors setting out into the unknown. On his first journey in 1492, fearing a mutiny, Columbus kept the compass's odd behaviour a secret from his crew. Even more troubling was the observation that at a given point on the Earth, magnetic north would move about over time. It's all one trip, because look, the fields keep going like this. Depending where you are, which direction you're going, or whether north or south. On his first journey, observed that magnetic north would... During the 17th century, after the pioneering work of William Gilbert, it was understood that the Earth itself was a giant magnetic dipole with which the compass interacted, but it was still a mystery as to why the compass did not point to north in the same way as one moved across the globe, particularly in an east-west direction. Imagine if you're sailing this way. Instead of your compass, showing north to your right, it's pulling back this way behind you before it curves back this way. Halley's interest in magnetism went back to his days at the blah blah blah, goes all the way down. I'll get right down to the bottom of that paragraph. In the years to follow, Halley would return to the study of terrestrial magnetism and compass variations. Terrestrial. He knew the sky. He knew the two systems. That's the magnetic field. That circular motion. These circular motions in the sky represent the magnetic field. We see the star trails do a full circle, but they're not it's not one star doing the full circle. They're doing this because the magnetic field flows this way and goes down through the Earth. But the stars are still being reflected from the centre, so they're still out there. Because as this centre turns, it's reflecting the stars out into the atmosphere. So you're always seeing the rotation. But the magnetic field flowing goes to the tropics, passes down through the Earth. But it's continuously flowing. Until the experimental work of Hans Ørsted, Michael Faraday and James Maxwell, brilliant theoretical synthesis, scientists viewed electricity and magnetism effects as separate and independent phenomena. Of the two, magnetism had received the earliest and most intense scrutiny from both scientific and technological perspectives. The imperatives of maritime trade and naval power drove the intense interest in magnetic phenomena. The study of terrestrial magnetism then opened the door to science and technology of electromagnetic phenomena that would follow in the next 2 centuries. Halley devoted much of his time to modelling and mapping the behaviour of the Earth's magnetic field. This grand ambition was to solve the age-old longitude problem through a better understanding of the Earth's magnetic field. You can imagine it's a problem, and it's still there today, but they've worked it all out. It's this GPS calculation. You have to do calculations to allow for the curve. I've said in the previous video, what they've done is they've taken these two curves here, you spin it back up this way, what have you got? You've got a curve going around a ball. That's what they've done. They've taken these curves, spun it round to create a continuous curve from north to south and made you think you live on a ball. But nothing is linear. Nothing is linear. You cannot travel from A to B in a straight line using a compass. I'm working on a flat earth map. I might show you if I've got time. Where are we up to? In 1963, Halley produced the first of many papers on the Earth's magnetic field. He argued that Earth was made up of an outer shell and a separate inner core. The outer shell and the separate inner core. Magnetic induction is the same system. The tropic is the gap. Each produced its own magnetic dipole. It was the motion of the inner core that produced the observed behavior of the terrestrial magnetism. He's basically stating exactly what I've been showing in all my videos. Although Halley's model was eventually proven wrong, but it's not, because they're thick. Or they're hiding it from you. They want you to think it's all been proven wrong. Though Halley's model was eventually proven wrong, his beliefs that the behavior of the planet's magnetic field had its origins deep in the core. Planet's magnetic field had its origins deep in the Earth core. Does resonate with the explanation that emerged in the 1950s. Now, because it's coming up out of here. This is the negative, comes up out of here. So it has to, from the core, but it's nothing to do with this, the centre of a spinning ball. The core is molten, and that's all just complete rubbish. Complex magnetohydrodynamic processes deep within the Earth, which are still not fully understood. They're never going to understand it until they understand the flat Earth model and how it works. Create the behavior of the magnetic field observed on the Earth's surface and above. More important, the science of terrestrial magnetism, from Halley's extensive work to map the variations. For Halley, the behavior of the variations held the key to solving another great problem. Before the video runs out, I'll let you know that. He discovered these field lines, and he said they're 11 degrees. Called them 11 degrees field lines, curves. I don't know how they came up with 11 degrees, but that's also got to do with it's science is involved with this, because here's a question online, but there's no answer unless you went and paid and joined the club. They don't give you these answers. They don't want the average guy to know them. When a charged particle moves at an angle of 11.1 degrees with respect to a magnetic field, it experiences a magnetic force of magnitude F. At what angle, less than 90 degrees, in brackets, with respect to this field, will this particle moving at the same speed experience magnetic force of magnitude? They've got the 1.1 degrees, but I can't get the answer. But back to what I'm reading here. Where am I? For Halley, the behavior of the variation held the key to solving another great problem in nautical navigation, the determination of longitude. Despite its critical importance, the practical determination of longitude at sea had long eluded the best minds. Latitude was fairly easy to determine, but without accurate longitude, one could never be sure where one was on the ocean. Errors in longitude led to considerable loss of life in ships. The maritime nation that could master longitude could more easily consolidate its command of the sea. The governments of all the maritime powers offered substantial prizes to anyone who could solve the longitude problem. I'm a couple of hundred years too late for making a lot of money. In addition to money, the solution of longitude also promised great honour and prestige. Halley was convinced that the eastward change and variation closely tied to changes in longitude. The idea was not new. It had been proposed several times during the course of the 17th century. See, science wants you to think, because of this magnetic field going west, they want you to think a spinning ball is rolling east. So because the ball is rolling east, everything's moving west. Oh, they're so stupid. And people are so gullible to think they live on a ball. Oh my goodness. Halley's great contribution was the invention of the isogonic map. He set out the map the lines of constant variation over the Earth's surface. Just like this is his map. I just showed earlier on. The hope was that lines of constant variation could somehow be translated in a one-to-one manner to longitude. In 1963, with the full support of the Royal Society, Halley proposed to the government that it fund a voyage around the world in order to measure and map the phenomenon of variation as a way of determining longitude. Queen Mary II approved all of elements in Halley's petition. The outbreak of hostilities with France delayed Halley's expedition. Finally, in 1698, set sail on the Paramour on a 52-foot vessel built for the expedition. The Admiralty had reduced the geographic range of Halley's investigation to the North and South Atlantic. Halley's only experience at sea had been as a passenger, and yet in an astonishing move, the Royal Navy gave Halley command of the Paramour. Halley returned to England within a year. Shortly after his return, Halley set out on a second expedition to measure the magnetic variation. Halley's charting took him within 200 miles of the Antarctic. In 1701, based on all the data gathered, Halley produced the world's first isogonic chart of the North and South Atlantic Oceans. Throughout the first half of the 18th century, Halley continued to seek the solution to longitude problem through magnetism. The fix to use magnetic variation to solve the longitude problem stopped when reliable